linear combinations of normal variables, calculating probabilities. Example 1. Abby has to complete two tasks, X and Y. The time taken to complete each of the tasks is normally distributed as follows. So for task X, the mean is 20 minutes with a standard deviation of 2 minutes, and for Y, the mean is 25 and a standard deviation 3. Now we want to calculate the probability that the total time taken. Now the total time taken to do something will be the time taken to complete task X and task Y. So we need a new normal variable, X plus Y, the total time taken. So the mean will be the mean of X plus the mean of Y, which is 20 plus 25. And the variance, and we only ever add variances and not standard deviations. So the variance here is 2 squared, which is 4. The variance here is 3 squared, which is 9. So 4 plus 9. So the variance is 13. And what we're calculating is less than 42. So we want the probability that X plus Y, the total time, is less than 42. So now we just need to standardize the 42 using our new mean and variance. So we have our standardizing formula. The value we're standardizing is 42. Remember that X in this formula is just a general random variable. It's not the same as the X here. So 42 X minus the mean 45 divided by, and we're dividing by a standard deviation, this value here is a variance. We have to square root the variance to get the standard deviation. So we have our Z value, we've standardized. So we're now working out the probability that Z is less than minus 0.83. This is the small area in the sketch that we're looking for. Because it's a small area, we need to do 1 minus to the probability that we look up from the tables. So looking up 0.83 in the normal tables, so these are Z values, 0.83 gives us this probability, and we're going to do 1 minus to this. And the final answer. This sketch has a horizontal axis representing our variable X plus Y, which had a mean of 45, and we wanted less than 42, so we shade to the left. We can do the sketch in terms of the standard normal variable Z instead, in which case we have Z values along here, so 0 always goes in the center. Our Z value here is minus 0.83 and so on. Okay, part 2. The probability that the time taken to complete task X is greater than the time taken for task Y. So we want to work out this, that X is greater than Y. Now to work out this probability, we need to have all of our letters on the left hand side. So think of it like this. If this was an equation, you'd have x equals y. Taking the y to the other side, so you're subtracting y from each side, so now you've got x minus y is equal to 0. Yeah, y minus y is 0. Except here, we've got this inequality. We're saying that x is greater than y. So minus y from each side, so you've got x minus y is greater than, and y minus y is 0. This is what we need to work with. So x minus y is a new normal variable, and we need to work out the mean and variance for this normal variable. 0 is the value that we're going to standardize to calculate the probability. So to work out the mean, it's the mean of x minus the mean of y. 20 minus 25. So that's minus 5. We only ever add variances. So 2 squared plus 3 squared, 4 plus 9. So we have our normal distribution for x minus y, and we're working out the probability that x minus y is greater than 0. This is the value that we're going to standardize. The standardizing formula, so the value we standardize is 0, which goes here, minus the mean, and the mean is minus 5. Be careful with the signs here. Divided by the standard deviation. The variance is 13, the standard deviation is the square root of 13. So z is 1.39. This normal distribution is in terms of this variable, x minus y. The mean is minus 5 in the center. 0 is on the right hand side. It says more than, the arrow is pointing to the right, we shade to the right. It's the small area shaded, so we need to do 1 minus to the probability that we look up from the tables. So z, 1.39, gives this probability, and 1 minus that to 3 significant figures is 0.0823. Again, the sketch could have been in terms of z values instead of the normal variable x minus y along here, and then it would look like this. Same answer.